In this video, I'm going to do the response on page 13, 2011, Form B, number 4. And it says, consider a differentiable function, f having domain of all positive real numbers for which it's known where f prime equals this equation, for x is greater than 0. So just notice it can't equal 0. Any x values you use need to be greater than 0. So for question A, it says find the x-coordinates of the critical points and then determine is it going to be a relative maximum, minimum, or neither. So when you see critical points, you should know that we're going to take f prime of x and set it equal to 0, or undefined, but you don't have undefined unless that's a rational function. So we're going to take 4 minus x times x to the negative 3 and set it equal to 0. So this is like factors. Anytime you have two things multiplied together to equal 0, you can separate it, set them both equal to 0. So this one would give you 4 equals x if you move x over. And then this one, anytime you have x to the power of, that could be negative, it could be a fraction, it just equals 0, and there's nothing else. It's going to be 0. No matter what you do. If it makes you more comfortable to actually solve it, what I would do is change that negative exponent to be 1 over x to the power of positive 3. Right, that's what a negative exponent does, bring it to the denominator. Now I could move over, that would be, or you could also, because if you move this over, then it's going to be 0 times x cubed, it's going to go away and just be 0, and you have no solution. Or you could think about it as making it a, well, you're still going to do 0 times that, and it's going to go away, and it's going to be no solution. That is never, 1 divided by anything is never going to be 0, basically. So you don't need that. I don't know where I was going with that. Even if you thought this was 0, let's say, that's still not in the domain. So even if you did solve this wrong and you got 0, well, 0 wasn't in your domain, so hopefully you still didn't even use it, and you just have the critical number 4. So you draw a number line, or a sign chart. We're going to put 4, and when you pick a number less than, I wouldn't pick 0 because it's not in your domain, so I'm going to pick 1, and I'll pick 5, and you plug them back into the derivative. So when I plug in 1, it'd be 4 minus 1 times 1 to the negative 3. So 4 minus 1 is 3. Now 1, again, a negative exponent just brings it to the bottom. So that'd be like times 1 over 1 to the positive 3. Or you could have just brought it underneath the 3 also would have been correct. Which that's still just 1, so that equals 3 times 1, which is, at the end, that's going to be a positive. That's what we care about. Over here, we're going to plug in 5, so that would be 4 minus 5 times 5 to the power of negative 3. So 4 minus 5 becomes a negative 1. Now 5 to the power of negative 3, again, is just going to bring it to the bottom. 1 over 5 to the power positive 3. So we don't really care what that is. Remember, we're just caring about negative and positive. This is a negative. Times that's just a really small positive, but there's no way that ever becomes negative. So that becomes a negative. So we can see that at 4, the derivative switches from positive to negative, which that means the slope goes from positive to negative, so that creates a maximum. So we'll say there is a relative maximum at x equals 4, because you have to write this out. Your sign chart does not justify. Write out what you did. F prime of x switches from positive to negative. Okay, so then part B says find all intervals on which the graph f is concave down. So how do we know when it's concave down? That is when f double prime of x is negative, right? That's what we're looking for. So you got to do a same process, but you got to use f double prime and then create a sign chart, and you're going to see when it's negative. So we got to get f double prime. So we got to take the derivative of our f prime, so we're going to have to use product rule, right? So I'm going to go ahead and write down my f prime since I'm on a different sheet of paper. You don't have to write this down on your free response, grading wise. And now I'm going to use product rule, so 4 minus x is my first, x to the negative 3 is my second. And another thing you could do is rearrange this and use quotient rule. Just thinking in my head, but I'm going to go ahead and stick with what I said, product rule. So, original second times the derivative of the first, which would be negative 1, plus, now you switch it, the original first times the derivative of the second, which would be negative 3x, you subtract 1 to the negative 4. We clean this up, that would be negative x to the negative 3 plus, or you know what, I should have distributed this. I'm going to distribute this to each term. So that's going to be negative 12 x to the negative 4, and then that becomes plus, what? My coefficient's 3, and then this is a 1, and when you multiply you add exponents. So 1 plus negative 4 would be negative 3. So then we can combine our like terms, the x's to the negative 3's, which would be negative 1 plus 3 is 2, so that'd be 2x to the negative 3 minus 12x to the negative 4. And then we could take out like term, right? So what do those have in common? Is they both have a 2 and they both have a x to the negative 3. So then that would be left with 1 minus 6 x to the negative 1.